Yeah, so this technology, actually, this enhancement brought to us by this Microsoft framework, the SQL Server, the TSQL, the Transact SQL. What is the benefit? What is the use of such technology, actually? Briefly, we are just answering. Briefly, actually, we are seeing a new perspective. We are seeing a new way how to deal with the projects that they use actually databases as a back engine, a back tool, a back solution. So to deal with the database in background, actually, we are referring to advanced technological views. We are not just integrating a bulk of data and that's it. No, we are considering the security as a perspective, and we are planning to make the project in question run with a very good actually trust and let's say affordability, feasibility, and so on. So the TSQL is an enhancement to support that. We see actually a very clear uh, stable list of let's say stable transactions being actually set on question, and with privacy and let's say uh, feasibility and efficiency raised up. So the TSQL, we continue on that. Actually, we defined where and we passed through other necessary related issues and concerns. Great. So remember that actually it is a small briefing here, and remember that the actually the TSQL helps us in doing the live update of the database to uh, from a local or an offline database into an online database without off time, and this is actually due to the use and due to the help of the snapshot usage, the backpack files, the data tier application component package files. Then on top of that, there will be actually a chain script used to check up the modifications. Once yes validated, there will be actually an update. It is a context of just bringing the necessary updates, which are either to be a create or an alter statement to be passed. They might be actually list of create and list of alter statements if needed or if necessary, or depends on the scenario, to pass from the local to the online one, or from the offline to the online database. Backpack. Snapshots actually, once they actually considered to be shown an update that has to be actually influencing the online database, the content of the snapshot would be deserialized into the online one. In the sense of, remember that the snapshot, it is a view that has an object of all the components. It has actually representation of all the components or the objects of the real database. The snapshot, it does not have to have the data of the database, but it has to have actually an object that represents every, let's say, an instance that represents every object from the real database. The snapshot, it has to have an instance of every object from the database. Thus, once it is to be utilized to update the online database, the content or the snapshot actually would be deserialized, means the contents, those instances, they would be pushed to the online database one by one. This is the first use. But later on, the snapshot, since it is having an instance of the real database, actually an instance of all objects from the real database. So later on, for a reason or another, actually, when a developer does not have an access to the real database, actually the snapshot, it would serve in helping him to continue his job on this snapshot as if he's dealing with the real database. An instance from every object inside the database. What does it mean? It means the full database architecture is available. The full database actually is drawn. It is visible to the database. So it is, sorry, it is visible to the administrator. Okay. A small question actually to summarize. The frame schema actually compare between the developer snapshot and the live database can be done using what? The comparison here. The question is asking about the comparison. And between what? The snapshot that the developer is using and Rodina has come. Join in now. Okay. Welcome Rodina. And why you are late, ya Rodina? Developer snapshot actually and the live database. This would be done using what? Can you answer the question, please? I just need the suggestions from your side. Are you able to recognize what is the answer of this question? So the answer here, actually, I'd like to bring your attention to is that it is to be answered by this chain script. The chain script would be actually tackling this context. The chain script would be tackling this concern. The comparison that would be happening from the one when developing and the one in live means in the real one. The chain script would be actually doing this comparison. It would not be done manually. It would be done using the change script. Remember that. Is it clear, please?
Yes, clear, Mister.
Yes, great. Then the SSDT actually it is one of the APIs that we utilize to connect from front end to the database engine, DBMS. The SSDT. This SSDT actually it is one of the solutions, standalone solutions that we can use to remotely connect to the database engine, DBMS. What does it mean? It means actually we would have different versions, distributions from this SSDT. 2012, 2013, 14, 15, 19. Those are actually distributions that we may stand on to use as an API to connect to the DBMS. Okay, we are starting, for example, a project using the SSDT, for example, 2012 distribution. The V actually is the 2012. Okay. After a while, the administrator has asked us to change to the distribution 2019. Is there any issue? No, absolutely no. The SSDT would help us. The SSDT would help us to migrate from a version to another. But actually, it is to move from the old to the new, not the vice versa. We want to move from an old version to a new version. This would be very fine, and it would actually be very fluent and, let's say, smoothly happening. Yet, if we want to move from the 19, for example, to the 12, no, this won't happen. There are constraints we have to consider. There are so many constraints we have to consider here. It will not be actually as easy as when we move from the old to the new one. SSDT actually has the capability to help us as developers to move from an old distribution to a new one. Great. Yes, also from another perspective, technically speaking, and from a real plane, the SSDT, once we deal with it, actually, as if we are dealing with the Visual Studio, as if we are dealing with the SSMS we saw in the lab and whatever, all of them, they are actually having an interface graphical view that we can deal with. So working with the SSDT, let me just, the objectives here, as I said, it is just to deal with the remote connection with the database engine, which is in our case the SQL Server. Good. And one very important notice is that it is a conclusion to what we were talking here, that the SSDT has distributions and we can go from an old version to another one, to migrate from an old distribution to a new one, is that the updates brought to an SSDT does not influence the SSDT does not influence the DBMS or the DB in question, DB engine in question. What does it mean? If we update the SSDT, does not mean we have to update the SQL Server or the database management system, DBMS. No, they are irrelevant. Actually, they are actually from the same producer or procurement company. Yes, Microsoft. Yet Updates brought to SSDT, to the SQL Server data tool, does not by consequence mean that we have to update the engine, the DBMS engine. No, because even the most updated versions of the SSDT can give us actually a chance to remotely connect to an old DBMS. Still, there are considerations, restrictions of the libraries that we are going to use. But even though, because actually some functionalities from within the database management system inside a new SQL server, they're not supported by an old SSDT. See what I'm saying? Not the vice versa. And a new SSDT would support all the functionalities, totality of the functionalities available within an old SQL server, DBMS. The libraries or the functionalities or the predefined procedures, stored procedures actually available inside the DBMS would be supported by a newer SSDT API. The vice versa, no, it's not. A known SSDT cannot support the totality of a newer DBMS. Trivial, no? We are going to visualize something which is not available, its place. But we are having the place of all old in addition to a newer places. So yes, we can. You have to understand it this way. A common sense understanding is the preview of the Server Explorer, where we can see actually the database in question. Remember that our book is describing the SQL Server as an implementation context. Authentication, remember in the last class, actually, I insisted on that you have to activate the mixed mode in authentication. Why? Because actually it would give us actually the chance to utilize the admin account to control the logins and the security hives from within the API and from within the database itself, database engine itself. So the mixed mode, it would give us actually the a wider range to have actually the administrator account to have more, let's say, flexibility and functionalities that we can use or refer to add more control to our works on real plane. Yes, this is what I was saying. This is due to this what we are seeing here due to the admin account. We are able to control all of those logins, credentials of logins, the users. We are able to control them one by one, and so on. An example of a query via actually this is a simple SQL query via which we are just stating that we are going to use an existing database, use the name of the database, and so on. So simple query, simple SQL does not need any effort from you. You have to be aware of this. You have to be aware completely because this is simple DB, let's say, task. It is a query to create a database and a query to use a database. Objects that actually can be seen and utilized, explored, having the benefit of from within the SSDT when working with the SSDT itself. So we presented once upon time last class exactly and specifically the schemas, and we said that those are cover the schema in singular. It is a cover to a group of objects from within the database. As per the physical hierarchy we saw at the beginning of this unit, we said that the database is inside a database management system, and the database management system is inside a server, and the server actually is available hosted somewhere remotely. Good. From the objects that we find in between the database and the server, the DBMS, the schemas. The schema in singular, it is a cover that holds a group of objects from within the database itself. Objects like the tables, very common, very easy. So tables related to students, student subjects, students semester registration semesters, students grades, and so on. All of those tables, they are in just one schema. Courses names, courses departments, courses colleges, This is another schema, and so on. So every group of related entities and objects, they are in a separate schema, just to facilitate the work later on, and the control also. Schema and schemas. Also, using the SSDT, we can control the snapshots, the generation of snapshots. The distribution we installed from the model is an express edition. It's an express edition. It does not have the totality. It's an express, literally said. It's an express edition. We do not have the totality of the functions that the SQL Server gives us. Amongst the functionalities that we are limited to create is the generation of a snapshot. Snapshot cannot be created by an SQL Server Express edition. But what is it? As we said and as we theoretically defined, it is a view of all objects inside the DBMS seen in abstract. Inside an abstract means actually we don't need to have the data itself, the values inside. We just have the object architecture to control the database, to use it later on for creation of a change script or something like that. Table is the very common entity and object you can find inside a database. Stored procedures is new to us here. This is the first time we meet it in this course, the stored procedures. This is a sort of a function that does not have a return as per the definition. This is a procedure. But stored, why? Because we are going to use it again and again. We are going to define a process, procedure, it's a process, a select, for example, or an insert, or maybe an alter, or a create, something like that. This process, if it is common, we are going to store it and use it again and again and again and again whenever it's needed. So no need to write the procedure again or the process again. No need to create the process again. We just create it once and we save it. We save it where? Inside the SSDT actually memory, wherever it's actually given us the space. So stored procedure, it's a process to be utilized more than one time inside the project or during the lifetime of the project. So we can generate a process named procedure and we save it from within the body of the project. As we have the chance to deal with the objects inside an SSDT, actually we are dealing with the creation of objects inside the SSDT actually workspace. The same way actually we can deal with creating all the objects or all the actually what we defined earlier, but in script way. Actually, whenever we talk about the TSQL, so we are going to create a script to do the task, the respective task, or the respective list of tasks. So it's using the query editor. It's using the query editor. So we can do that using the queries or the query editor, which is a space where we can actually manipulate all. This is the query editor, is the space on top, this square here, the space on top, this is the query editor. We can actually implement all of our TSQL space here. Actually, a simple activity, but we are going to see it in lab. Not here. Just I'm going to explain this the request here. We are required to create two entities, customers and orders, and then after we are required to generate actually a view to summarize the customers' orders. So we have customers list and we have orders list. Then we are required to generate a view to summarize the customers' orders. The customers one by one ordered. We do that. So select the orders actually grouped by customers. Select the orders grouped by customers. Simply, it's a simple SQL query. It's just one query. We see the solution. We will see the solution. Yeah. So we are going to create a view, something like this. This is actually, it's from the book only. So we are going to create a view. We give it any name. Actually, where we are going to make some manipulations. It's a simple select. See, it's a simple select. that has a beginning and end. That's it. It's just one select group by. That's it. But we have at the beginning, create a view and we give it a name. Simply like that. All what we see here in this, actually it's from the book only, is just the creation of the entities, the customer and the orders. The customer and the orders. So at the end of the day, here the view, what is it? The view actually is a simple block that specifies a beginning and an ending of a transaction, whatever the transaction is willing to do. And this example here is to summarize the customer's orders. Customer number 1, what did he order? Customer number 2, what did he order? Customer number 3, what did he order? And so on. All the customers, one by one, each, what did he order? Simple. This is simple select. Simple select. Grouped by. Grouped by customer. Oh, yes, by customer. Customer ID, customer name. No more, no less. But it is inside the view because the question is asking us to make it a view. So it is to have a start and an end. Begin actually from here and ends here. In between, we have the query. It's one query, only one select that fits this question. One select, it fits exactly what this question is asking us. Okay, the generation of an object inside a database and the generation or creation of a view like or something like that, process like the view, or creation of stored procedure like the one we defined earlier, which is a process to be stored, uh, does not mean that we are stick at that architecture or at that solution only. No, at any time during the lifetime of the project, we can gather new requirements and we can update the project architecture. During the lifetime of the database, at any time we can generate a new view because of the new gathered requirements. There is no restriction. Don't say that we created a stored procedure, we saved it, that's it, we cannot modify it, we just stick at that. After 1 day, after 1 week, we have to use only that architecture. No, no, no. If we need other modifications because of new requirements, yes, we can make these updates, whatever the time is, since the database is still alive, or since the project in totality is still in use. Is it clear here, please?
Yes, Mr. Clear.
Great.
Yes.
That's great. That's good. That's good. Okay, the table designer is another view via which we can actually go by generating the respective actually entities inside the database using a graphical view, no more, no less. It gives us actually a rich experience to deal with the generation of objects graphically with the respect of the secure approaches. We are not going to do it without any. Actually, it helps us build graphically with a secure perspective or secure view. So it is trustful to use it. Don't say that we have to go only with the code. No, no, no. The table designer is one of the positive assistants when dealing with the SQL Server or the SSDT as an API. Working with SSDT. So here, in conclusion, it is the role of the SSDT to generate whatever the table or the entity we are in question we are willing to generate. So it is the role of the SSDT to do that. So we are not going to use the SSDT. Sorry, we are not going to use the SQL Server to create a table. Now remember that we are connected to the SQL Server remotely. So it is the role of the SSDT to do whatever we need actually as chain script to make updates, to generate actually a view, to send it to the SQL server, to the database management system, or whatever. It is the role of the API. In our context, here is the SSDT. Our API here is the SSDT. We don't use the SQL server itself as an engine to create a view. We use the SSDT, we use the API to generate a view. The question says that an SQL server is used to create a view. Answer is false. There are usages we can use from within the SQL server. Yes, we see that in future, not in this unit. But for now, it is the role. Remember that it is the role of the SSDT to generate, as per an example of the chain script. Yes. I'll explain only the connected mode, the context of the connected mode, but just one, those activities actually we will solve all inside the lab, inshallah. Regarding the use of the SSDT when dealing with the SSDT, actually, we have two of the options, either in disconnected mode or in connected mode. What is the meaning of this or that? Either we are going to specify a path from within the API to the DBMS in question continuously. Otherwise, we are going to specify a path only for the time of the use. It means from the beginning of the use of the project until you close your computer or your session or whatever the device we're using, a continuous use of the SSDT to connect to an entity or the list of the entities available in a database. There is a memory used and there is a channel used. There is a bin continuously alive. This is a connected mode. Here, actually, you may say, so what is the problem? Why we're talking this way? Because when we use a memory and we use a channel dedicated to connect to an entity from within the DBMS, we are allocating a process to only serve one channel. It cannot serve other channels. If there are other requests, they would be actually put into a waiting list. This causes a process to not serve anybody else. Thus, this connected mode, since it is actually having a positive side, it also have a drawback, which is actually, as I said, it puts other requests in waiting lists, or it uses memory for, it occupies space in memory and so on. The disconnected mode, it is a little bit, we can see that it is actually consuming more time maybe, because every time we need something from the database, we have to achieve actually a connection, a new bin and a new connection to the entity in question. We retrieve the data, and then after we disconnect. Yet, it is actually to literally say to serve more users, since it uses only the resource as per its need. We need it for 1 second, we use for 1 second only. We need it for one connection and one query to execute. We execute the query and we terminate the connection. We free the entity in question. So the decision to go for the connected mode or the disconnected mode when you are just generating or creating a project, it is based on the constraints or the request of the project itself. Otherwise, you have to consider the time constraint, and you go for the connected mode maybe, if it's fitting your resources. Any questions at this point, please, in the context of the connected and disconnected mode? Any questions, please?
No, Mister.
Okay, that's great. Another example actually it answers the question we were talking here, which is the generation of the chain script. It is from the book only. It is literally said from our resource only, from our reference only. Actually, I'll stop here because we have to prepare for something else. I'll stop the recording and I'll take the attendance now. If you hear your name, just say